Good afternoon, everyone. Good afternoon. I hope you all had a great weekend. Welcome to the Georgia Tech Manufacturing Institute Spring 2023 Lunch and Learn Lecture Series. My name is Dr. Billy D. Brown. I'm a Senior Research Faculty and Education Workforce Development Director at GTMI. Excited to continue hosting this series and encourage you to please spread the word so we can grow our network, which provides value to the GTMI community. Before I introduce today's speaker, I will first introduce GTMI and provide some brief instructions for the audience. GTMI is one of 11 Georgia Tech Interdisciplinary Research Institutes that uniquely focuses on manufacturing research, development, and deployment. We help tackle the grand challenges of today's manufacturers and assist partners in moving innovations from the lab to the market. GTMI has a wide variety of facilities and equipment on our main campus for basic research, as more applied research nearby on 14th Street in our advanced manufacturing pilot facility. GTMI's mission includes education and workforce training, collaborative partnerships with industry, academia, and government, as well as thought leadership. GTMI hosts the Lunch and Learn series each semester. These sessions are excellent opportunities for Georgia Tech faculty, undergraduate and graduate level students and researchers, as well as the global manufacturing community to share advanced manufacturing knowledge. Today is our second lecture for this spring, and we're both in person and streaming online via Zoom. We want these sessions to be interactive, so please, if you're online, put your questions in the chat. If you're in person, jot down your questions, and the speaker will address them briefly at the end of the presentation. All right, today it is my pleasure to introduce Lance Ferguson, who will discuss pivoting JTEKT products and manufacturing in light of electrification and transportation. Lance is currently the Director of Engineering and Innovation at JTEKT's Technical Center in Greenville, South Carolina. For the past few years, Lance has been involved in developing and expanding JTEKT's approach to innovation and new product development. The first 20+ years of his career involved broad experience in improving manufacturing competitiveness and developing technology. From advanced development as a technical specialist to strategic decision-making as a member of the global operations team for leadership. In today's presentation, Lance will actually give an overview of JTEKT, a top 20 global automotive supplier and maker of steering and driveline systems, bearings, and machine tools. As the transportation sector transitions to electrification, JTEKT must adapt its products, its manufacturing, to meet customer needs. Demand may decline for some products, while new products will be developed and launched that require new capabilities. JTEKT's Technical Center in Greenville, South Carolina is currently working to identify gaps that need to be closed, as well as new product opportunities that fit their design and manufacturing capabilities. Lance, the floor is yours.
Thank you very much. All right, thanks everybody for having me today. For the introduction, Dr. Brown. So, I'll add a little bit to the background there. I graduated from Georgia Tech in '92 with an ME degree. Subsequently came back and got a master's degree in ME as well as I was working. But I don't think I've been back to the campus for at least 10 years. So it's great to be back here and see how things have changed. I started out working in grinding development with a company called the Torrington Company. It was a bearing company. Over the years, I moved into engineering management. The company got sold a couple times, now part of JTEKT. And I spent most of my career in the manufacturing technology side of things. In the last 5 years, I've moved over to product development. But it's really the relationship between manufacturing and product that I want to talk about to you today and the impact of electrification.
Right. Working out? There we go. Okay. Just had to click on the screen there.
No problem. All right. So just a few comments about JTEKT on a few slides here. So top 20 automotive supplier, 17 technical centers around the world. I'm from the one in Greenville, South Carolina. Also have one in Detroit in the US, 82 manufacturing plants. So, pretty big player in the global automotive industry. About a $13 billion company. Kind of see the breakdown. We're about 50% in steering and related systems for automotive. Another 11% for driveline type components for automotive. And then bearings, 27% of the company, and probably 60% of that's automotive, the rest industrial, and also machine tools. So if you've heard of Toyota machine tools, that's a part of JTEKT. This shows kind of our US footprint. So you see a lot of manufacturing in the Southeast in Georgia, South Carolina, Tennessee. We also have one plant in Canada, one in Mexico, and some other distribution centers. The three in Georgia are heavily related to a product we call needle bearings, thin section bearings. A lot of applications, but one of the biggest is for automotive transmission. So electrification is certainly a big impact of that product. And just a few of the customer names, you can see a lot of the biggest automotive companies and some of the bigger industrial names as well, Caterpillar, John Deere, GE, etc. So as I mentioned, so I'm from the Technical Center in Greenville, South Carolina. We're on the ICAR campus, and we pretty much have everything in the building related to product design and testing and manufacturing development that we need to develop new product and process technologies and then distribute those to the plant that we have in the town. Okay, so when it comes to electrification, I'm really just going to touch on the impact in two quick slides. I'm not going to really get into like forecasts of electrification and automotive. There's lots of them out there. We've just determined as a company that it's significant enough that it matters to us and the products we make today. And one reason you can see from this graph, on the left you have the Chevy Bolt, on the right you have the VW Golf. This analysis is pretty old, it's maybe from 2017, but the same thing applies whether you're talking about a Tesla or anything else. You see the number of moving or wearing parts going from 167 down to 35. So if you've ever seen an EV out on a table, it's just dramatically simpler than an internal combustion engine vehicle. And not only does this then affect the potential volumes of automotive suppliers, but now you've got all these automotive suppliers competing over basically less real estate in a vehicle, so a lot of competition. So from the beginning of any new product for electrified vehicles, you're going to have a lot of competition. So cost and quality, meaning your manufacturing, is going to be extremely important. This isn't a case where you can launch some new product with high margins. It's competition from day one. This also just illustrates from a engineering development standpoint, this just relatively shows our current customer programs and our application engineering group for bearings for BEV versus hybrid versus ICE engines or ICE vehicles. And you can see it's, there's almost no work going on right now on ICE vehicles. So regardless of what the volume forecast is, the development is happening in electric vehicles. So how does electrification affect us? So some of our products like CV, J's, half shaft, steering, differential systems, those are going to still be in EVs. But pumps is to the degree that we made them for oil pumps for transmissions and engines aren't going to be the same. So those are definitely affected. On the bearing side, certainly some of our engine products that we would make for V6 or V8 engines aren't going to be as prevalent, and in the hubs will still be needed, be a focus on say low friction hubs. For the bearing business, there's still going to be bearings, but there may be less, and there could be a mix change, which also has significant implications for us. An example of the mix change I'm talking about, if you just look at, these are a couple of different of the common EV drive types, where you've got a 3-axis design with your motor at the first axis, like a gear reduction on the second axis and your differential on the third axis. Whereas with a coaxial, those are all kind of in one line. You can see the 3-axis would take up less axial space, The coaxial would take up less radial space, so you're seeing some differences in how those are applied in a car versus a truck or an SUV and kind of where they need space. But for us, the 3-axis type is like almost all ball bearings, whereas the coaxial is a combination of ball and roller bearings. If you look at a current automatic transmission, those are going to be a lot of roller bearing. So for us, the first EVs were a big shift in the type of bearing. It was a significant issue for us. We're just still studying, okay, and trying to be abreast of it. What way is the technology going to go? So kind of with that in mind, say 5 or 6 years ago, we were kind of seeing that what I just described was going to happen. We were looking at, okay, what are the opportunities for us in the future? So what we looked at, if I just kind of plot, trend-driven change on the bottom, and to the right is some positive trend for the volume of the product. The left will be a negative trend. High on the y-axis will be good capability. Clearly, we want something in the upper right, something that's got good volume potential for the future and a good capability fit. And we were really trying to, look at our current manufacturing capabilities and engineering capabilities as a part of it. When we started looking for ideas and we kind of asked our company and other folks for ideas, we kind of get a few different categories of ideas. We either get just things that were in the news at the time, drones, EV batteries, but things that didn't fit us. Yeah, there's a few bearings in drones, but that's not, where most of the value comes. Those things didn't really fit us. You get ideas like, well, just motor shafts. Hey, there's going to be more electric motor shafts. Yeah, to some degree, but those are already being made today, right? What are we bringing that's unique to that? Then we would get just a lot of parts that look like things that we would make today. Like, okay, maybe let's take a look into that. What we found over time, and I'll go into that a little more, just because it kind of looked like something we made, that didn't really mean it was a good fit for us because it didn't take advantage of all of our skill sets. And then with a lot of this stuff, it was automotive related to ICE engines over time. Certainly we knew that was going to probably drop faster than people thought, 5 years ago. A lot of the industry were saying, okay, yeah, electrification maybe after 2030. Obviously that's happened faster. So we really were left with, okay, not a lot of good opportunities identified. So what we did was we really tried to make sure we understood what is it that differentiates us today in terms of our manufacturing capability. And as we looked across our different product lines, and here's kind of the 3 Georgia plants, Cairo, DeLong, and Sylvania, and the products they make, what we learned was that it was a combination of capabilities that was important. It wasn't just stamping or just grinding. It was some start process like stamping or deep drawing combined with heat treat, sometimes specialty heat treats, our knowledge of materials tied to heat treat, and then some kind of precision finishing or assembly. And also linked with a strong application engineering and product testing knowledge. So we weren't just build to print. We were helping customers figure out how to satisfy their need through our manufacturing capability. So we learned it was really the combination of all those things that made us competitive. And so we needed to go look for those kind of things, not just things that people could see were made, in high volume today. Because if they're made in high volume today, somebody's already making them. They've already figured those things out. So one example of that in the EV world is if you look in the Ford Mach-E Planetary drive, there's lots of teardown videos about that. You can look in, it's got a coaxial planetary drive system. Within that is a long shaft because they have a step pinion system. So it required a shaft about twice as long as anything we had made previously. Ford was already a customer of ours. They asked us to basically help them make something that would work in this application. And, this is not an impressive part, right? To a lot of people, it's a shaft, right? But it's very important to have certain surface finish and roundness, lubrication features, life characteristics, and there's also some assembly features that all go into this. So there was extensive heading, induction heat treat, and grinding development in addition to the application knowledge and testing to make this work. So this was, a great example of that, what I just showed on that last slide. It was really the integration of all those things that was important, not any one of those capabilities. The next level we kind of looked into, again, as we're trying to pursue new opportunities through our manufacturing capabilities, was looking not at just one part of our company, but the whole company. So really, the company I'm a part of now, I've basically been with the same business for 30 years now, but we've been sold a couple times. That's represented the heritage of that company that goes back 100 years, kind of in the upper right. We were essentially merged in with a company that was also itself two companies that merged in 2006. So we really had three different company heritages there. And I think for probably a lot of companies that have had this kind of change over time, those things don't always just land nicely. You still have your different silos of knowledge and things like that. So we really tried to take a step back and say, okay, from our needle bearing technology, we have these competencies. What are the adjacent competencies elsewhere in the company? So we kind of tried to basically match those. Okay, we got stamping and drawing. We also have hot forging. We've got all kinds of heat treat, not vacuum, but we have it in the other part of the company. And we just started, putting all that together as a knowledge base to say, okay, now we can expand the capabilities as we go pursue new opportunities. And we reinforced that actually, this was important with an organizational change. So we took the process technology group that used to be split into different product types and we put them all together. So they had to all kind of start sharing knowledge and learning all those different technologies. We also defined, and this was something that's kind of important to me because for my first, say, 20 or so years, being strictly in the manufacturing side, I never felt like I had a great understanding of like what was the change in the product technology direction of our company. How should that be influencing what I was doing from a process development? I always felt like I was just developing the next better surface finish or the next better roundness or just higher speeds, right? I never really felt like I was linked into what was coming from the automotive market that would drive those. So for EVs, we wanted to make sure we're clear, okay, what is it we should be letting pace us in terms of development? This is just one of many things you can see where, efficiency is going to be one of the new dominant areas of interest for automotive. So the more efficient the powertrain is, the more range you can get, or the smaller the battery can be. And I think here you can learn something from ICE engines. If you kind of look over to the right, you'll see, fuel economy pretty much increasing across time from, even if you go back to the 50s, it just continually almost increased, even though we were increasing horsepower and weight. So there was just constant application of new technologies to improve the efficiency of the powertrain. You can see at the bottom, a lot of different ways that was accomplished: turbo, CVTs, GDI in the engine, just various ways. And what you can also see is that all the automotive suppliers kind of used all those, but not in the same combination. So I think what we can apply that to BEV is that you're going to see that drive architecture I showed earlier. They'll be evaluating which one can they get the most efficiency and the best packaging at the best cost. Disconnecting of like secondary drives where you have front and rear motors, different approaches to gearing or maybe multi-speeds, varying characteristics, and the OEMs may take different paths. So we're going to be constantly trying to figure out, I can imagine in 10 years, there'll be something like this for EV powertrain efficiency improvement. What manufacturing technology do we need to have to be ready for those advancements? To give you a couple examples of those, we, after kind of broadening our thinking about our capabilities, we have found a couple products that we're pursuing. I'll talk about a little bit in terms of electric braking and disconnecting technologies. In terms of electric braking, you're basically just talking about replacing the hydraulic braking system with a motor and ball screw on caliper. So that's already happening in parking brakes, and all the major braking companies are working on this to some degree for the future of EVs especially. But this really combined all the knowledge that I talked about earlier. There's forging, roll forming, machining, heat treat, thread grinding, precision assembly, and testing. And in Greenville, we make things, we put them together, we test them. We're constantly looking at how can we make it more efficient. How can we get higher load and a higher force to apply the brake caliper in a smaller package, all those things. So that integration of all that manufacturing and assembly, sometimes I was guilty of it as a grinding guy. assembly somebody else's problem. But, you know, here we've got to really think about all that through testing. And there's just a quick iteration cycle because we're all in one location. Same thing for basically a linear actuator, stamping, heading, machining, broaching, heat treat, again, assembly and inspection, prototyping and testing. All done kind of concurrently and trying to share that information with customers, get their feedback. We're also making prototypes. We validated, give it to them for them to do their own testing. Another area we looked into was, okay, so we looked across the company. We kind of now understand the breadth. What about where we have depth of knowledge? So we felt that forming, and especially sheet metal forming that we do for those needle bearings, we've got a lot of knowledge in terms of material characterization that we can feed into our FEA models to make them more valid. We've got all the tool design and forming equipment, stamping presses or whatever technology. What out there could be something we could look into? And so one of the things we're exploring now, it's still very early, is bipolar plates for fuel cells. Some of which are stamped from sometimes titanium, but a lot of times stainless steel. And before I get a little more into that a little more, maybe just to talk about our process for developing and launching new products. Of course, it ends with winning and launching business. In the middle is actually developing the product, but at the early stages, we're working on something we call discovery. You're not really trying to develop the product, but you're trying to develop it enough that you can answer some of the biggest questions. Sometimes those questions are product design related, sometimes they're manufacturing related. So what we're trying to do, say with manufacturing technology, not wait till we design something to then figure out how to make it, but to have that be part of the process. And in this case, for fuel cell bipolar plates, it's even, should we even go into that based on our manufacturing capability? So what we did for bipolar plate, again, similar to what I talked about earlier, we looked across the company and we said, okay, we've got what we think is deep, thin sheet metal forming capability. We've also got some welding technology from cages and some other things that we do where we weld. We don't know laser welding, but we know how to look at the quality of welds. From elsewhere within the company, we've got coating technology, sealing technology, leak detection for oil pumps, and CFD, fluid analysis for varying lube. So none of those are exactly perfect, but they all give us some basis of knowledge. But then we said, but we still have some holes. We don't really understand laser welding of the size needed for this application. We don't understand the design of the bipolar plate. So this is where another element of our activity is to pull in some partners to help us close those gaps. So in this case, we're using what's called the South Carolina Fraunhofer Alliance. So this is a German institute that has knowledge in various things. Bipolar plates for fuel cells happen to be one of them. They're helping us with the bipolar plate fundamental design. They're also going to do some of the initial welding and coating for us. And then this Clemson is coming in because we've never done the material testing on this thin of a stainless before. So they're helping us fill in the blanks there. And the FEA for this thin stuff is also a little different, helping there. So we're really trying to define, again, across the company, what capabilities do we have? And then where can we fill in the gaps? And really what we're going to do with this one is, take what we've done and then try to go into the market and say, hey, is there a need for JTEKT in this market? The answer may be no. And we may stop this, within 3 months or so, or we may define a target to go after, or maybe we'll find somebody to work. Part of the reason we're doing this is this has happened before in our company. We have this plant in South Carolina that made knitting needles in the 60s and 70s. In the late 70s, they transitioned over to thrust bearings driven largely by automatic transmissions going from 3 speeds to, even lately 10 speeds. So maybe the future could be something like bipolar plates, but it's not that. We're looking for the next thing for really all of the plants that we're responsible for. So in summary, just some of the things that I talked about. I think it's important, again, to understand the true value proposition for your manufacturing capabilities. Don't look at them just as individual pieces, but how they come together to the whole value stream, including your engineering design capability. Look across the total company because you may have to blend things that have never been blended before. understand where you have depth of knowledge, search for trends and product opportunities to align with those manufacturing capabilities and help that drive your, say, roadmap for manufacturing technology, find partners to close gaps that you have, and then explore that kind of product and process interaction and differentiation early in your exploration through that collaboration of all those different functions. So that's all I have. Take any questions.
All right. You have any questions?
I'll ask one.
Yeah, sure.
I'm the communications guy, not the engineering student here. There's a lot of great stuff on the slides. So I saw the development into the, the electrical part of the business. Internal combustion engines are still going to be around.
Right.
How long do you think you're going to still make parts for ICE vehicles?
All I can say is through our, say, midterm planning, they're still in there, But for us, it's kind of like the designs are set. We even have some new stuff that's launching, and we expect it to be around for several years. It's just to also show like just the engineering activity with OEMs is all shifted to EVs. So what we see is we'll keep making it as long as they make the ICE engines. And in the meantime, we'll work with them on the development of the technologies for EVs. So it's kind of hard to say, it's really dependent on what the OEMs, different strategies are for how long they keep doing it. But I mean, I could see them continuing to just make them, just not do any new technology changes.
So to follow on that, but Billy,
Yeah.
very cool stuff, right? In the home, but to follow on that, I mean, there are lots of conversations on this. I mean, when does it become, in your thinking, just not a viable industry, right? I mean, at some point in time, the numbers drop so low that JTEKT's going to say not interested. I mean, just as another one, we're also talking about gas stations.
Yeah.
Well, what happens as we get fewer and fewer gasoline-powered engines?
Yeah.
When does BP and Shell, when they say, well, it's not even worth having gas stations anymore? And they're, by the way, I think part of their plan is going to be to morph over to just little shopping malls and stuff, because they make all their money on selling other stuff besides gas. But I mean, what do you think might happen there in terms of when it's become not worthwhile?
Right. So I think that's still a ways out, just because we make bearings for other applications as well. And I think you're going to see electrification in other areas drive the need for more bearings. Anytime you replace hydraulics with a motor, probably got a gear reduction, you got some bearings at least anytime soon. I also, just think that, who knows how far, how fast EVs will ultimately go. You look at charging infrastructure, lithium supply, I mean, who knows? So we're just kind of looking at it. We kind of gave up trying to predict it and just said we need to be ready for either case. So if they keep making them, we have plans to keep making them. If EV volumes were to shoot up and ICE were to drop, we've got, plans around that too, just what we would do. So it's, I think what we've seen, even companies like GM, they gave us a presentation and where they said the key is just to be flexible. Nobody can predict,
So
that's what
can I follow on with that in terms of the flexibility, and I'll yield the floor to somebody else, but on the flexibility.
Yeah.
I mean, clearly, I mean, we've been working together for decades.
Right.
Clearly, your plants are much more flexible today than they were back in the 80s and 90s.
Right.
You see them becoming even more flexible and so forth. What are some of the key elements there that are going to allow you to pivot from making tons of, one type of component to something else?
Yeah, I think a lot of times, really, I use that example I just showed of the knitting needles. The plant, we didn't use the same equipment. We use the know-how, right? So I think in a lot of ways, it's the know-how of the workforce and it's the flexibility of the plant space, not so much the equipment. So I think we can be pretty nimble if we had to even change to a different product line. We'd still be using the infrastructure, the know-how, and the space. It just might be new capital. But I just think we're probably just better at, assessing that and understanding it. And again, we've, recently done big plant build outs and installations, we're using a lot more automation than we used to. So I think we're just better at those kind of things than we used to be in the past.
By the way, which was making the needle, the knitting needles?
That was in South Carolina, the Walhalla plant.
Walhalla?
Yeah, there's actually still a guy, he's now in my group that was there when, right at the end of the knitting needles, you know, so he kind of helped me, even just as a test case show, like that plant went from making knitting needles to bearings, a single component to an assembly, you know, and they did it, and it was all new equipment. It wasn't like they just, you know, reused the same equipment. It was still forming and cutting and, you know, heat treat. It was similar technology, but it wasn't the same equipment, right? It was, but you took the know-how of that workforce and applied it to new capital.
Yeah, I love it. By the way, just as an observation for all of you AI people out there, AI is never going to be able to help you transition from knitting needles to bearings, right? So good luck, ChatGPT. But you know, and so this is where you're going to get paid the big bucks to do it. I couldn't help myself there. Thanks.
There's a hand raised online. I think Horatio, do you want to make a comment or a question? You can unmute yourself.
Yes, hello, question. Thanks for the presentation, it was very interesting. You mentioned something about looking about your core competencies and how you can use them in the new, I guess, businesses that are coming in. And you did mention something about characterization of materials and something into simulations. My question is, how do you see, or how have you been using like digital technologies into your, I guess, your plans for you know, moving into these new products and businesses?
We're probably not necessarily on the cutting edge. We're a pretty conservative company. But we have, and I don't know if this is what you're getting into, but in some operations we'll have, say, QR coding that is recording, you know, the process variables that happen at key machines, then linked with the testing of that product, say with a steering system. And then within that information is also, say, data that we can use to try to optimize processes, whether that's quality or, you know, machine downtime or those kind of things. You know, we're not really doing anything, you know, too much like digital twin or anything. I mean, we're using, you know, CAD and FEA and all those kind of things. And I guess our interaction, like say, collaborative interaction between product and process is more just, you know, people interaction. But we are looking for how can we use, you know, data within the manufacturing process to align with test results to then help us influence, you know, future designs. You know, can we design out an issue we're having with scrap or whatever in manufacturing? Is that along the lines of your question, or are you thinking something different?
No, that is fine. I ask because there's clearly a gap in going from say your experience with a product into the new cycle and getting that experience to help into the new design cycle, say simulation. And I mentioned it because I saw the simulation image there, and this is not very streamlined. I mean, that's my, I guess, my take. It's not so streamlined. It's not like you can get the data. You mentioned QR, so you testing, and so you get data associated with that. But how do you use that for the next design cycle in which you're simulating things and trying to figure out how they're going to behave? So that was along the lines of my question, and I think, you know, I understand. Yeah, go ahead. Sorry.
That's the other thing I was going to add. So one thing we try to do is always have real-time testing to go with our simulation. So like we're doing forming simulation. We're also trying to follow up with the forming to educate that. And then we find we can iterate much better. But like, for instance, I showed that electric braking. A lot of that analysis is done at the FEA world or ANSYS. And then we're using that to inform the prototype decisions we make. We may try 2 or 3 things, get the results, see what did that correlate with? Do we need to tweak something? What we've seen, just say with the bipolar plate, is we needed new material data. We just didn't have the right data for the thin section material. Once we got the real data, we saw very good correlation with the real world stamping, and now that's helping us to move faster.
I had a question with the bipolar plate. What kind of sparked the interest in the bipolar plate? Is there some type of like fuel cell EV application?
Well, so Toyota, you know, has a fuel cell. They're pretty far along, but for us, it was kind of just seeing even maybe the heavy truck application, and just thinking that there's probably going to be some significant volume between that, or maybe even electrolyzers to make hydrogen. And then we kind of enlisted this front offer group with some other people. We did some market kind of interviews and just like, hey, is there a need for this? And it at least got us to the point of thinking, well, let's go make some very initial prototypes. Let's validate if our stamping and metrology and materials know-how is applicable. And what we've just kind of found is like, sometimes you just have to do something, to learn, right? So we're kind of taking a leap. Again, we may decide, it turned out to not be a good fit, but it was really just looking at the trends and thinking, okay, it looks like there's enough volume out there, say by 2030. So let's do some exploration.
Great talk, appreciate it, but specifically on the bearings, like
Right.
that you still have, you mentioned just reduction in the total number
Right.
in these vehicles, but
Right.
is there anything fundamentally different that you're having to look at or they're asking for? You mentioned coatings and efficiency,
Yeah.
but are there some different things about that particular environment,
Yeah,
the
so-
electric currents or
Yeah,
something?
so managing electric currents, so we're interested in coatings that can kind of prevent current from going into the bearings, or even conducting it to where you want it to be conducted to. There's a lot of talk about higher speeds, and that has been realized somewhat. I want to say we're in the maybe 20,000 RPM now. There's talk about 40,000, but I think that's one of the things you'll see is they'll be evaluating, should we go to 40,000 RPM, or should we do, and that which might require more gear reduction, or we not do that. So I think you're going to see a lot of change there, but a lot of this from the bearing application standpoint, just like loads and things, it's not that much different than an 8, 9, and 10-speed transmissions that we went through a few years ago.
On the transmission side,
Yeah.
I guess with JTEKT or Toyo and then Torrington, that was more roller.
Yep.
Focus, right? And maybe it's a little more ball.
Yeah, so Koyo was a big ball bearing company. There's just not a lot of footprint for that in the US. So there's more stuff being imported. But one of the things we just noticed with ball bearings also is they're more of an off the shelf product. And it kind of seems like when these first EVs were designed, they were thinking low volume, we want off the shelf stuff. So that could be one thing that led to the use of more ball bearings. But there's also, as I showed, like the 3-axis versus the coaxial. Sometimes the coaxial is too long to fit between the frame rails of whatever vehicle. So, I think we're just going to see a lot of experimentation, or not so much experimentation, trying different things. Different companies may take different paths. And then even like with heavy truck, we're involved in that too. There's a little more thinking, well, maybe you would have a 2 or 3 speed, transmission with the, in the EV. So those are all things we're kind of looking out for, but we're always interested in materials, herbology type, efficiency. I think you're going to see the need for efficiency improvement in whatever way we can find solutions for that.
So one other question, so in terms of supply chain going on,
Yes.
I wonder if you could talk a little bit about the balance. Okay, fewer components, so you got a lot of companies making all these components.
Right.
We're now gonna have fewer components, but you mentioned a couple of times sort of local supply, the whole bit. What's going on with supply chain? I keep hearing maybe companies are gonna go more towards point of assembly,
Yeah.
production and so forth.
The whole supply chain has certainly been a nightmare for, throughout the COVID times. So I definitely think that's going to be more in people's minds, and whether that's Mexico in combination with the US, we have a plant in Mexico for certain products, but, when we've recently quoted things, I don't recall there being any, well, they do have some percentages they have to hit, like say in content. I don't recall anything specifically driving a decision, but just that we're, in our own supply chain activities, we're trying to get as local as much as we can, just to take the risk, out of the system. And because of the types of components we deal with, maybe it's a different story for somebody else. You know, the precision and everything that we need, you know, we're trying to push local as much as possible. I'm just trying to think, I can't recall like any requirement or anything that we said other than the typical stuff that we've seen from the OEMs.
Yeah, I mean, what I'm hearing from a lot of the OEMs or primes and then the tier ones and twos is they're also looking local just because
Yeah.
it's been just really a mess. And so they're willing to pay a premium. I don't know what that premium is, but they're willing to pay somewhat of a premium to reduce that risk.
It's been a nightmare. I mean, literally, it's like just the only thing that our company was talking about for a year. You know?
Still going on.
It's better, much better in the last, say, 3 months or so. You go back a year ago, it was just constant monitoring. You know, we talked about the containers going from $3,000 to $40,000, just trying to get them, having to try to get contracts way out in advance just to secure material. It was just a huge, huge nightmare. Yes.
Kind of along those lines with supply chain, do you think with the reduction in parts, we might see more consolidation among the industry? I mean,
I think it's a big open question because there's definitely a ton of competition, you know. So I do kind of wonder how is some of that going to shake out, you know. So I definitely think, you know, it's going to depend how fast EVs actually happen, you know. Because right now, still making tons of parts for combustion engines, but
majority of what you sell.
but on the advanced side, you know, there's lots of people competing for the same types of devices, you know, whether you were, you know, there could be 5 different types of actuators, say in an ICE vehicle. Now there's 2. All those people are trying to come up with their own version of that. So yeah, it'll be interesting to see how that shakes out in the future.
Like with so many competitors, like how do companies differentiate between like each other and like how does manufacturing plays a part in that?
Yeah, so what I, you know, just what I've seen is not so much like an IP kind of thing. You know, it's like ultimately everybody kind of gets their own way. You know, even if somebody has a patent with you, then somebody else just gets their own patent to kind of get around it. I think it's a lot about just how quickly you can and how easily you can work with customers, how you can react to the changes that they have, and then you've got to find something that you're good at within that supply chain. And it can be different ways of doing it. Maybe some people, you know, if you're talking about a device with motors, maybe some people make their own motors, but maybe they're not as good with the, say, gear reduction or something, where somebody else is buying the motor, but they're good at the mechanical stuff. So ultimately it gets down to price. You know, it's not like in these things somebody's gonna pay twice as much for some performance thing. It's kind of like they figured out, or like one thing that happened with some of the EV stuff is like, take a disconnecting system to disconnect your secondary drive. They're just trying to achieve a range target for a given price. So if one technology is too expensive, then they may use a different technology that they feel gives them a better value proposition. So I think just trying to get back to your point, it's more so there's a spec, you need to meet the spec without anything extra because it's going to be kind of cost competitive, and your quality reputation definitely goes a long way. It's the same companies, you know, it's not like there's startups coming in on these kinds of components. It's the same companies with a quality reputation that have their advantage, you know, one way or another. But I think a lot of it is your ability to work with them. You know, they're trying to develop their product. They need samples, they need to validate, they need to get a quote in X amount of time. It's as much your ability to digest their spec and give them an offering, you know, that meets their price target in the right time. And there's lots of companies that can do it, but maybe not within the time, you know, that they need or the price.
Is there any additional questions? You see anything in the chat, Mary?
No. By the way, where is your plant in Mexico? Near Monterrey?
St. Louis, Potosi, I think. Not sure exactly what that's.
Okay, because one of the questions actually came from a colleague over in Monterrey, Mexico.
Okay.
I can tell by his voice, yeah.
Yeah. I haven't been there.
So this is probably a little outside this.
Yeah.
Your talk, but you guys are forecasting, or trying to forecast when
Yeah.
some transition will take
Right,
place.
right.
Any insight, any idea, as a consumer, for me right now, the electric cars are still, and I've seen this before over the years, but when the oil companies, all of a sudden the price comes way down.
Yeah.
Do you see from a supplier point of view, are you guys like fully committed going forward now? So what if the price of oil drops back down to where it becomes very, very difficult to compete with an electric car?
I think just because of that and because of what could happen with lithium, cobalt, whatever, you got all government mandate, all this stuff could change things dramatically one way or another. Honestly, I've just given up even trying to think about predicting it. Because I used to look at the numbers for like IHS, right? And they would have a curve for EVs. And then the next year, they'd have a curve for EVs. And then the next year, they'd have a curve for EVs. And I'm like, well, if they're just going to change it every year, what good was it when I first looked at it, right? So I've just kind of looked at it like, look, they're going to be here for our purposes. They're going to be here enough to matter. We just have to be ready regardless of what happens. Now, again, as a consumer, I don't have one yet because I'm not sure about these things catching fire and the other stuff. And, I'm just not ready yet. But again, to me, if you just look at it, they're much simpler, right? So my guess is that in time, they're going to be cheaper to make. And even though they're a premium now, I just think in time that will drop down once they figure out batteries better and you get more efficiencies. The battery can be smaller or whatever. But whether that's going to happen in 3 years or 10 years, who knows? Hard to say.
The other thing, I'll just chime in, the other thing from a policy perspective, when you've got California, it's California, New York, several other big states have already said you can't sell internal combustion engine vehicles after, was it 2035?
35, I think.
Yeah, so when they say that, basically, now I was actually reading into this. You can go to Nevada, you can live in California, go to Nevada and buy one and then come back across the border. But when you've got these major states saying, this is how we're going to do it, you're kind of stuck, right? And then you're going to turn around, then GM's going to say, and you've already seen it with Ford in Europe. They said by 2030 or 35, they're not producing internal combustion engine vehicles in Europe. And it's not going to be worth it, right? So when you get these big states, at least in the US, making these calls, yeah, everybody's going to follow along. This is where, so the whole EPA thing, they've had these battles about, well, is California driving EPA? In general, the federal government in particular, whatever administration is in place, likes California to do that, whether they agree or not, because then they don't have to take it on. Should we have it going up? Should we have it going up? California's done it. And we're, pretty much all the automotive companies are going to follow along, with their regulations because they're not producing two different kinds of vehicles. So the federal government just says, hey, that really wasn't our call. California made us, California drove it and we're kind of stuck with it.
Yeah, but I think GM and Ford, all those companies, I think they're doing it because they think that's the right thing to do. I don't think they're doing it for marketing or whatever. I just, but they can also keep making, they're just launching a new V8 that we're supplying parts into. So I think they'll just kind of keep doing it. And, they've moved tons of cost out of the ICE vehicle side. They're not really doing any, much development there. So they're probably like, well, we can just keep making these until we see what happens with EVs and how fast, they take off.
I was just thinking probably not a great idea to transition all the way to electrification, right? But and be totally dependent on the grid,
Yeah.
right?
Yeah.
I think having multiple energy technologies makes sense and redundancy.
And that's kind of what Toyota is saying. People say they've been kind of slow with their position is you're going to need a variety of things to make this transition. Which makes a lot of sense.
All right. Well, that was a great discussion, everyone. And we want to thank our speaker one more time. Walter, I was just curious because we have a nice crowd here. If you maybe want to do a picture.
If everybody would like to go to the front of the room, we'd love to have a group photo.
Okay. Okay, and while you guys are doing that, I'll just make a brief announcement. So next week, we're going to have Scott Herron He's the Executive Vice President, Chief Financial Officer of Cisco. He'll be visiting and speaking in our series. Going to discuss how Cisco made a quick, difficult business and operations adjustments to respond to the Russian invasion of Ukraine. So I think that's going to be a very fascinating.
That's gonna be a good one.
Yeah, I mean, one of the things we're trying to do, just sort of follow up is I think it's okay if we have seminars on, well, let's add another hydrogen atom to some blah, 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 and sort of figure it out. But to get a little bit of a different feel. So this one here, clearly electric vehicles are coming. How are you dealing with it? What about some of the supply chain issues? So some stuff to think about. Next week with Scott Heron, I think it's going to also be very interesting. I think one of the questions when you're looking at companies, you should ask, hey, how did you deal with this crisis? What about your people in Russia? What about your people in Ukraine or Belarus? How did you deal with it? I think it'll give you a feel for what type of company you might be employed by, right? Did you just say, well, hey, the government said this and that was it? Or did you try and help these people out and so forth? I think you're going to see a very interesting one. By the way, the other thing, Cisco is all about networking and so forth. So you could imagine, oh, well, okay, Cisco had to shut everything down, all the networks and so forth in Russia because they can't support it. Easier said than done. He may talk about things like the hospitals that they're supporting. You can't just shut network system down in a hospital. So lots of things to think about. I tell you, so we're trying to give you a little bit different perspective, on some of these different things. Fix your time?
Yeah.
I heard that too.
We'll go ahead and end the meeting online.
Please go.
Hello, Thomas. Hi.